Hey there, today we'll be doing this question that appeared in today's daily challenge, that's combination sum 4. And the question statement is, given an array of distinct integer nums and target integer target, return the number of possible combinations that up to the target. And that is the question. So let's understand the question in a better way with an example. So mind you, the question was misleading to me at first. Why will I say that? Since they said the number of combinations, right, which are forming this target. So by the way, for this question you need to know recursion and dp in order to do this. Okay, so these are the two prerequisites to this question. So how do we sum this up to the target? So this is a similar problem which is somewhat very similar to coin change 2 if you have done it in the Leetcode. Okay, and if you have not, I'll link it up in the description box. That is the coin change 2 problem. Fine, if you have not checked it out, do try to check that out also. Fine, so now let's understand this part. So it's saying that we need to make all the possible combinations. So target can be found by what? We can take 1 4 times, right? So this is one of the combinations. So mind you, in this problem, which is exactly similar to the coin change 2 problem, you can take a coin infinite number of times, right? So this is one of the possible combinations, that is 1111. And mind you, when you take 112, so 112, this also leads us to 4, right? So they have also said that a possible combination could be a different arrangement of this uh, summation also. That means if I have taken 112, I could also take 211, which actually forms 4. So this is where the question actually changes a little bit. In coin change 2, you just have to find if you can do it or not by using some number of coins, right? Or not some number, infinite number of coins. But here you have to take this combination part also. But I think this is actually a permutation which they could have mentioned, since permutation means you could arrange it in any way and you will still get 4 right here, right? So a better way to say this is the number of permutations of some number of coins which actually lead us to uh, the target, that is 4. So this is what you have to find. So now let's directly get on to how to do this. So since you know that if I'm at some index, let's just say that if you have these coins with you and the target is 4, I'll be taking this example only. So what they have said, you can go and take 1. Now when you move ahead, let's just say you are moving ahead, you are not taking that 1 again. Okay, let's just take that up for now. If you are moving ahead, that is, let's just say we took 1. Now when we take 2, now they are saying that we can again go back to 1. So this is just the statement. Okay, so this is what you have to take care of, that you can again move back to 1 and choose it, right? So how do we simulate this part, that going back and forth, right? So again, if you want, you can go to the last index also, then also again you can come back to the second index or the first index. Okay, so how do you simulate this part? That is the only thing that you need to know in this one, and you'll be good to go for the solution part also. So what you can do is, you know, that we'll be trying all the possible ways, right? So what can we do? What can we do if we want to go back again to the 0th index, again to the first index or the second index or the third index or the last index? What do we do? And I think you might have guessed it, we can use something like a for loop inside of a recursion in order to go back to the 0th index or the first index. So what can we do? We can just take a for loop which will go from 0 to n, right? We can go from 0 to n, and what we will do, we will take all the possible combinations of this. Let's just say I is ranging from 0 to n, wherein n is the size of nums array. What we can say, we will take every possible combination of nums of I. That means, let's just dry run it once. So if I have something like a for loop which says I is equals to 0 to n, right? And what can I do? Here will be some statements for the recursion part. Let's just say f is the function which is calling the recursion, and I can take the ith index. Okay, so what will f of I do? So let's just see how the function call works. So f of I, At first, what is the value of I? It will say 0. Fine, you take on 0. Now the I plus plus will happen. I will increment. It will go on to 1. Now again it will go on to 2, right? So this is what happens. Now, mind you, when this f of 2 recursion call happens and it tries to go further, it will not be able to go further. Then what will happen? Another recursion call for f of 0 will start. Now why so? Because we know that in every recursion call every recursion call is happening inside a for loop. So for every recursive call that you are calling, so that is 0, 1 and 2, since the size is 3 here, a for loop will be called for this one from I is equals to 0 to n. Okay, so this is what happens in every call. So in every call, I is equals to 0 to n will be called. So here also 0 to n will be called. Here also I is equals to 0 to n will be called. And so on in every recursion call. As it happens, this will happen simultaneously for every call. Okay, so this is the basic thing that you need to take care of, that is make the recursive call inside a for loop such that it can go to the first index or the second index at each time. Like here, again I'll just explain you. When I'm calling for f of 1, okay, when it backtracks from f of 2 to f of 1, what happens is f of 1 can now go from I is equals to 0 to n. Why? Since I am calling this recursive function inside the loop. Okay, so this is one of the things that you need to take care of. Now let's just get on to the code part, since I've understood the explanation of this one, and I hope you have checked out the coin change 2 problem as well, since it is very similar to that. So yeah, this is a DB problem, since the size of the nums length is 200, right? So we need to actually take DB, otherwise it will give a TLE, since the time complexity goes exponential. So let's just see. So I've created the DB of size target plus 1 and initialized it with -1, similar to the coin change one. I'm telling you again. And this part, that if target is 0 we return a 1, if target is less than 0 we return a 0. Why so? Again, I'm telling you, please do watch that coin change 2, just try it once. Okay, then you'll understand this part very much clear, since it is exactly similar to that one. So target is equals to 0 means that I have actually formed the target, so we can return a 1. If target becomes less than 0, it means we need to return a 0. Why so? Because we could not form a target. And if I've previously visited that state, that is the target, what do I return? I just return a DP of target again. And what is this loop doing? As I said in the explanation, what are we doing? We are ranging from 0 to n, 0 to n, and inside this we are calling the function, that is for this guy, right? And every time, mind you, the target decreases by nums of j. If I'm choosing the nums of j, the target decreases by that part, right? Obviously it will decrease. Since I've already chosen it, my target will decrease. Now for the next one, again a function call will be made, and for again a function call we will go from 0 to n. Okay, so this is how the loop continues and makes a function call each time for each part. Okay, so yeah, this is it for this code, and at the end we are just returning the take function that is called right here. And yeah, this is it for this video, and I've already submitted this code. And if you do want this code, I'll also be pasting the link to this code in the description. If you want it, you can check it out from there. And I've already submitted this code, so don't worry about the submitting part. You can check it, it's a working code. And yeah, if you did understand this code and the explanation, please do like and subscribe.